Today we are going to look at solving inequalities with variables on both sides. So some things to remember is just that when we multiply or divide by a negative to solve, that we need to flip the inequality sign. Okay, so if we look at this first one, right, if we go through those same steps that we talked about earlier in the trimester, you can use all of those from equations, but remember our rule says if there are variables on both sides of the equal sign, in this case inequality sign, then we have to move one of them with the opposite sign. So we can choose whether we want to move the 2 or the 8, it doesn't matter. So if I choose to move this positive 2w, then I'm going to subtract that 2w on both sides. Okay, so my 2w's will cancel out. That'll leave me with a negative 9 is greater than or equal to a 6w plus 11. Then we will undo addition with subtraction. Subtraction is never a reason to flip the sign, so that will give me negative 20. And then I will undo multiplication with division, so I'll divide both sides by 6. Okay, so negative 20 divided by 6. I can simplify that. I divided by a positive 6, so again, the 20 is negative, that doesn't matter. I divided by a positive, so I do not flip the sign. But I am going to want to flip that inequality sign to rewrite it with the variable first. And whether you leave that as a negative 10/3 in improper fraction form or as a mixed number, just no rounding. Okay, so if we look at our second one here, we have a negative sitting in front of this set of parentheses. So we need to distribute that negative 1. So I'm going to take negative 1 times 2x, which gives me a negative 2x. And negative 2 times a positive 1, which gives me a negative 1. Here I did multiply, okay, but I'm not moving it to solve. This is just simplifying, so that is not a reason to flip the inequality sign. Okay, then over here I have some like terms, so 5x plus 3x gives me an 8x. I have variables on both sides of the equal sign, so I'm going to move a negative 2x by adding 2x. And I will undo multiplication with division. So I'm going to divide both sides by 10. I'm dividing by a positive, so that is not a reason to flip the inequality sign, and I'll get x is greater than negative 1 over 10. My next one here, right, I have this large fraction bar. So to move that, I'm going to multiply by that 4. I can't get my variables together until I get that one out of the fraction. So those cancel out. So I'll get 6y minus 8. It's greater than a 32y. I have variables on both sides. You could move either way, but remember, we never want an empty aside. So if I were to move this 32y, there'd be nothing on this side, and that's not going to help me. So instead, I'm going to move a positive 6y by subtracting 6y. Be really careful with your signs. That leaves you with a negative 8. Okay, so that'll give me a 26y. I'll undo multiplication with division. Right, I'm dividing, but I'm dividing by a positive, so that's not a reason to flip the sign. I do want to make sure that this gets simplified. And then I can rewrite this with the variable first. We're going to look at one more here when we're solving. So I have parentheses, so I can distribute my 1/2, right? No different than I would distribute with any other number. This is going to become a 1/2 x, and a 1/2 times a 14, or half of 14, is 7. Now, we've talked about a couple options on this, right? We could multiply this entire equation by 4, right? Because that would be our common denominator. If you chose to multiply this entire equation by 4, you'd have to make sure you multiply by 4 here, 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 and here, and that would be completely fine. The other option that we have talked about is just using a calculator to help you with those fractions and doing our inverse operations no differently than we normally would, and saying, okay, I have variables on both sides, so I can move a positive 1/2 x by subtracting 1/2 x. right? And you could use a calculator to do that math, and you'll get 1/4 x minus 10 is less than or equal to 7. Undo subtracting 10 by adding 10. And again, some of you are thinking about this as dividing by 1/4. Some of you are thinking about this as multiplying by 4 because you're multiplying by the denominator. Some of you are doing this as multiplying by the reciprocal. Any of those are completely fair options, right? That just leaves me with a 1x, which is the same thing as x, 68. Now, same as before, when we allow there to be variables on both sides, we kind of open the door for some other things to happen, right? So sometimes our variable will cancel out and we can be left with a false statement. And sometimes our variable will cancel out and we'll be left with a true statement. Now, these are the exact same rules that we had before. If we get a false statement, we are going to say that our answer is no solution. And if we get a true statement, we're going to say our answer is all real numbers, right? That's the same definition that we gave before. The difference is today that our interpretation is a little bit more unique. Okay, so if I look at this gives me a 3x plus 18, right? I'm distributing. So I have variables on both sides. I can move that by subtracting a 3x. But right, 3x minus 3x cancels out on both sides. And it is very tempting for my students to say that those aren't the same number, and so that's a false statement. But what we're really asking ourselves is 18 greater than -1? And the answer to that is yes, 18 is greater than -1. So this is a true statement. And this would be our all real numbers. Okay, so if I look at this one over here, I have variables on the same side. So I can get them together with the same sign, right? I'm saying 2h plus 8h. I'm always looking directly in front. Subtract those. So I have -5, right? These cancel on both sides. So I have -5 is greater than 3, right? This is a false statement. -5 is not greater than 3. That's a false statement. So this is our no solution.